Assalamualaikum and very good morning everyone. Welcome back to Computer Science lecture. We are now in lecture 3. So we are still here in topic 1. If you still remember, in topic 1 we have 4 subtopics: system concept, number system and representation, information coding scheme, and logic gate and simple logic circuit. Okay, we are in number system and representation. Last week, in second lecture, I have explained to you data representation in computer. This one, right? About bit and byte. Okay, so now we are going to look at the second part. The second part in number system and representation, which I'm going to separate it in two. Which the first part we are going to look at definition of number systems and why some number system is used in representing data in computer, and the second part is about number conversion. We are going to look at number conversion between 3 number systems. Alright, in this topic we have actually 5. Initially we have 5 learning outcomes, but I have added 1, which is B. So now I have 6 learning outcomes. Which the first one, A, is already covered. Now for this video only, we are going to cover learning outcomes B and C. I'm going to explain to you about number system, and I'm going to explain to you a little bit about why binary and hexadecimal numbers are the only number system used to represent data. Okay, conversion of numbers in the second part of video. So, what is number system? Okay, number system is a set of numerals for representing numbers. Numerals means symbols or digits or any figure which represents or denote a number. So, 3 common number systems are decimal number system, binary number system, and hexadecimal number system. The first one is decimal number system. This actually is the number system that we are using every day. So maybe I don't have to explain much about this. It is also called base 10 number system because it uses 10 digits, which is 0 to 9. And we form numbers by combining any of these digits from 0 to 9. For example, number 18 is formed by combining digit 1 and 8, and so on. And there is actually one thing that I want to mention here. Why is decimal number system is called base 10? It is actually called base 10 because it relates to the base in the place value of decimal number system. We know that each number in decimal, for example 18, each digit in the number has a place value. In the number 18, for example, digit 8 is 10 to the power of 0, which is 8 ones. That's why the value is 8, right? And digit 1 has a place value of 10 to the power of 1, meaning it is 1 times 10. So the value is 10. 10 plus 8 is 18. So the base 10 is actually comes from here. Okay, we call it base 10 because the base in place values are 10. Alright. We are going to look further about this in conversion of numbers later. The second number system that we are going to discuss is binary number system, which also called base 2 number system. It uses the two digits only, that is 0 and 1. And we form numbers in binary number system by combining zeros and ones, and it's going to look like this one. Alright, and this is also called base 10 because the base in place value is 2 to the power of 0, to the power of 1, and so on. The next number system that we are going to discuss is hexadecimal number system. Hexa means 6 and decimal is 10, so hexadecimal is base 16, right? Base 16 number system that uses 16 symbols. The first sentence here is a description of this number system, meaning if you are asked to describe base 16 number system, or describe hexadecimal number system, you are going to give this sentence, right? Okay, so in base 16 number system, we have to have 16 digits or 16 symbols to represent the values from 0 to 15. So since in decimal we only have 0 to 9, to represent the next value here, for example, look at this table, from 0 to 9, okay, we still have decimal symbols to represent 0 to 9 in hexadecimal. So it's just the same. From 0 to 9 in decimal is the same as hexadecimal 0 to 9. But to represent 10 in hexadecimal, we cannot use 1 and 0 because 1 has a meaning and 0 has a meaning already. So we have to use another symbol, which we adopt letters A, B, C to F to represent the value 10, 11, 12, 13, 14, and 15. That's why if we look at any hexadecimal number, we might find these letters together with digits. Or it can be only digits, it can be letters combined with digits, because these letters actually has value. A is 10, right? D is 13, right? So this is how we form hexadecimal numbers. And base 16 also comes from place value in hexadecimal number system, which the base is 16. Next, there is a little bit about why these binary digits and hexadecimal numbers is found when we are talking about data representation in computer. Why sometimes we found binary digits are used, and sometimes we can see that hexadecimal numbers are also used. Okay, to explain this, for binary digits, as we have seen earlier, binary digits are the most suitable system to represent data in computer because it has two distinct digits. It has only 0 and 1, which is match the states in computer, which is the states of on and off. So it provides simplicity. That's the first reason. The second reason is since it is directly related to 0 and 1 relates to on and off, it means no translation time. So it provides fast execution time or access time. The second point. The third point is talking about the use of space and energy consumption and cost in setting up circuitry in computer. This relates to the when we talk about the designing or the setup of the hardware of computers. Okay. Maybe you will have to read more about this, and if you have questions later, we can discuss more in tutorial class. And hexadecimal numbers also used in data representation. We found hexadecimal numbers when representing addresses in internet. For example, IP address. We are going to look at hexadecimal numbers are used there. So hexadecimal numbers is used primarily, firstly, because it is more efficient. It can represent more efficiently than binary number system. For example, the value 2002 in decimal requires 8 binary digits. If we use binary, right, 8 binary digits, meaning we have to use 8 symbols or 8 digits, while hexadecimal can represent the same value using only 2 symbols, C, A, base 16. So we are comparing it when representing decimal value. Okay, we are comparing hexadecimal to binary here when representing a decimal number. Hexadecimal can represent more efficiently compared to binary number system. The second point is a little bit different in the sense of view. Okay, hexadecimal number system can represent large binary numbers in a simpler form. Now we are looking at hexadecimal number. Why hexadecimal number is used to represent large binary numbers instead of decimal number or any other system, right? So hexadecimal number system are very compact, and it is easy to convert from hexadecimal number to binary number, and vice versa. We are looking at why hexadecimal numbers are used to represent binary, not other system, right? So because hexadecimal is easier to compare to binary, we can see this earlier. I'm not going to explain this further now because it is going to be very vague. Now, I think that's all for the first part of the discussion in topic 1.2. So the summary here, you should be able to define those number systems. Yeah, there might be questions like this, and also from experience we have seen that there are questions like the advantage or benefit or reasons why binary numbers are used, and also advantage or benefit or reasons why hexadecimal numbers are used in representing data in computer. So that's all for now. Thank you.